Hello YouTube. Today we're going to work on some statistical studies and cases. I'm just going to go over some basic stuff about statistics and how types of studies are done, and then we'll go through some examples and look at some bias as well. Okay, so statistics. Pretty much it's the analysis of data. Every field pretty much on the face of this planet, every business produces data. You've probably have heard of big data. If not, it's fine, but that's one example. But there's always transactions. Everything involves data, some sort of number. So what statistics does is we read this data and we try to read it quote unquote correctly. And we can also find some extra useful information that can be used to help in pretty much every field. So let's go through some examples of the types of studies that are done. There are experimental studies and there are observational studies, and one of the answers is kind of given for that first part, but when we get to the example, but to define what an experimental study is and an observational study. So experimental is when a researcher assigns the treatments randomly, and that's the key, randomly, to individuals. Observational studies are when the researcher has no control over assigning treatments to individuals. So an example of an experimental study would be to have a random number generator or something like that, using along those lines of random to do some sort of experiment along random lines, so using some sort of mathematical analysis. While observational study, your research has you have no control. You kind of just observe and watch. Those definitions weren't too good, but hopefully these examples will help clarify what exactly an experimental study and an observational study is. So if you can notice, here's an investigation about taking aspirin reduces the chance of getting a heart attack. What kind of study would that be? That would be an experimental study. Because that would be the best way to observe it. You would have to see, doctors have to have a control group, so where they give like a placebo pill. That would be part of the control group of the experimental study, and then they actually give the aspirin to the experimental group to see if it really does reduce the chance of heart attack. So, whoops, what did I do here? Uh-oh. That's not good. This isn't going as I planned. Okay, so I'm just going to do this. Oh yeah. So would you have to do a double blind test or a blind test? And a blind test versus a double blind test, pretty much double blind means that the researcher nor the experimentals know what the experiment is about. Single blind test or just a blind test is where one side is unaware of an outcome. So this case, for example, would be a double blind test. That would be best used to make sure that bias does not interfere. So both the doctor who is prescribing the aspirin and the patient taking the aspirin should not know that they're involved in this study. So that they aren't influenced. If doctors know that the person's taking a placebo and they might ask certain questions during the experiment and the study, that might lead to the person taking the drug not thinking it's the actual drug anymore, or vice versa. If the doctor is assigned the actual drug to the patient and the patient's not responding how the doctor was hoping it would do, that would lead to bias. Okay, so next question. If babies are born in poor families, they are more likely to weigh less than 5.5 pounds than if they were born into wealthy families. So so this study is about, I guess, wealthy versus poor baby births, around 5.5 pounds. So what kind of study would this be? Well, this would be an observational study, because you just have to weigh the baby and see how much it is. But the question is, would you have to do a blind test or a double blind test? Whoops, over here. Blind testing. Pretty much, it would be, for the person weighing the babies would have to be blind, because if they were like, oh, this person is from a poor family, or this is from a wealthy family, they shouldn't know. They should just weigh the baby and be done and be over with it. So they're just unaware of the outcome. Next one. So the investigation is the size of A plain commissioner of weight. Oh, okay. Wait a minute. Okay, I understand this. Okay, so this word here sounds like a brain, part of the brain. Okay, so the size of the part of a brain of a man related to sexual orientation. So I guess depending on the size, it might relate to how the person identifies themselves with sexual orientation. This would be an observational study. You can't really do like a control group or an experiment. You can't really do that. It has to be observational. There's no other way to determine. So this would be a blind test as well. It should be done for the person determining the size of the brain, because if the doctor believes that a larger size or smaller size determines sexual orientation, then they'll be influenced and biased in the decision-making process when it comes to analyzing the statistical data. Okay, so now we're going to move on completely to another section here. So this one is just identifying the bias. And so if you have 800 volunteers that were recruited from a nightclub to in an experiment to evaluate the treatment for social anxiety, what would be the bias? Well, look at here. They're from nightclubs, and that's pretty much the main thing here. Let's see what I put. So yeah, it's the nightclubs. There were volunteers from nightclubs to talk about social anxiety. It's obviously clearly biased. And one way to I guess make sure it's less biased or change that would be to diversify your samples by going to multiple locations and having non-volunteers, maybe, if that's possible, and again doing like a random number generator and assigning like an X number of individuals to participate in your study. Okay, let's do another one. So a water pollution study. All the samples were collected from a stream for 15 rainy days. So if you only collected when it was raining, there's obviously a lot of flooding that goes on. So there's definitely bias when it comes to pollution, because the more it rains and stuff goes down drain, it's usually collected and gathered and washed away, and your study of water pollution would be biased. So yeah, that's the bias, because it's only on rainy days. One other possible solution I kind of came up with was just collect it for each season and make it a really long-term study to really see the water pollution, how it affects the environment there. So I guess that'll be it for now. This is a pretty long video, so I'll make another one. But this was just some ideas of experimental versus observational studies and identifying biases, as well as looking at blind versus double-blind testing. Hope this helped. Remember, examples and practicing is key. Think of a situation or look for one and try to identify if there are biases in a certain study. And the point I'm trying to make for statistics in general, I guess, is to look if there is bias. By the way a study is portrayed in a magazine or an article or online. See if the reader or if the author wants you to believe a certain way, if they're trying to persuade you. So if they're trying to persuade you, it's that's kind of a bias there too. And look if their study really makes sense. If they were to, if an observational study would suffice, because sometimes drawing conclusions from an observational study is not always the correct or right way. Although it may look like it, it might not be. But anyway, hope this helps, and happy studying.